Now, my dear children, we will discuss in detail about the working of p-n junction diode in forward biasing. Now, basically, remember this point, children, that in the absence of any external field, like if you are not connecting p-n junction diode with a battery or cell, then there is no current flows to the junction diode, p-n junction diode. Okay, a few majority charge carrier, okay, that say present in like hole in the p region and electrons are the majority charge carrier in n region, okay, however have energy to move across the junction against the barrier field. The barrier field means the internal field set up within the p-n junction diode. Okay, but this current is exactly balanced by the reverse current flows to the flow of minority charge carrier. And what is minority charge carrier? Mean p type, p region, electrons are the minority charge carrier and holes are the minority charge carrier n region. Okay, so with this what happened? We can even see that there is no current flows in the p-n junction diode. That means the net current which flows in the p-n junction diode, if p-n junction diode is not connected with an external circuit, is 0. But however, the junction diode can be connected with the external battery or cell. And in what way we can connect it? Two ways. One we have learned already. One is called forward biasing, one is called reverse biasing. Now we are going to discuss in detail about the forward biasing of p-n junction diode. And you know that a junction diode is said to be forward biasing when the p terminal, when the p side, this is the p region or p side of the p-n junction diode is connected to positive terminal, and n region or n side of the p-n junction diode connected to negative terminal. This is with higher potential, this is with lower potential. Then we can say that this p-n junction diode is under what bias? Forward bias. So children, this particular circuit diagram which is shown out here is the circuit diagram of forward biasing of p-n junction diode. Now as soon as this p-n junction diode is connected with the forward biasing, then this battery or cell provide external electric field to a p-n junction diode. And then external electric field is marked by letter E. So E is the external electric field that is supplied by this cell or battery, and electric field always directs from positive terminal to what terminal? Negative terminal. But you know that when the p-n junction diode is formed, there is a junction which is formed. This is called junction. Okay. So as soon as the p-n junction diode is formed, there is a region which is created, and this region is called depletion region. So this is a depletion region. You can see the dotted region which has done is called what region? Depletion region. And due to this depletion region, there are the diffusion of electron and hole takes place at the junction. Okay. And due to that, there will be a potential which is created. This potential will be positive potential because of this positive charge ions which form, and this is negative potential which is formed due to the hole that moves from this p region to n region. So with this what happened, there is some voltage which set up between the region, and this voltage is called barrier voltage. We call as what voltage? Barrier voltage. And this barrier voltage is marked by letter BB. So BB, children, is also called potential barrier. This is called potential what? Barrier, or also called what voltage? Barrier voltage. We also call what voltage? Barrier voltage. Okay. Now due to this voltage which is set up, or potential barrier which is set up, there will be a field set up inside the p-n junction diode, and that field is called internal electric field, which set up from positive terminal to negative terminal. So this arrow you can see in the diagram. This arrow means there is a field which is set up inside the p-n junction diode, and this electric field is marked by letter EI. So EI is the internal electric field which is set up within the p-n junction diode. Okay. So under this case, what happened? The external electric field, as you can see, E, is set up by the cell or battery to the p-n junction diode, and internal electric field is set up within the p-n junction diode due to this barrier potential. Okay. But in this case, your E will be greater than EI. So external electric field will be greater than EI, and E is in a direction opposite to EI. So your EI is this side, your electric field is this side. So under this condition, you can see P region, which consists of holes, are the majority charge carrier. See, these are all holes. And you know holes are the what carrier? Majority charge carrier. And N region, these are the electrons. These are the electrons, and electrons are the what? Majority charge carrier. other than hole, there are the electrons, very few electrons which are present in the p region, that is called minority charge carrier, where this is a hole which are also present in the n region, which act as what? Minority charge carrier. But as soon as this p-n junction diode is connected with under forward biasing, this electric field, which is more than this field, helps the hole of p region to move towards the junction, and also makes the electron in n region to move towards the junction. So you can see even in the diagram, the holes of p region as a majority charge carrier and electron in the n region as the majority charge carrier are moved towards the junction. Once this electron and hole, which are the majority charge carrier of p region and n region, are moved towards the junction, then as soon as they combine, as soon as they combine each other at the junction, okay, then what happens? A covalent bond breaks in the p region. So when one hole combine with electron in the junction, there is a covalent bond breaks in the p region, and due to this covalent bond which breaks in the p region, okay, near the positive terminal of the battery, means at this end, one electron will eject from this region, that is called electron, and this electron is a free electron. But as soon as covalent bond breaks near the p region, so that electron moves from this region as a free electron, then there will be hole which is created in the region and it moves toward the junction. So as soon as the electron moves from this end, there will be electron from this negative terminal move at this end, and the electron movement from this negative terminal battery will enter into this n region. So this process continues till whatever number of electrons and hole they recombine at the junction. So as soon as the electron and hole start recombining at the junction, then more covalent bond will break at the p region, so that free electrons from the p region move in this way. So free electron move in this way, and this free electron even emit from this negative terminal, because this is a p-n junction diode, whereas this is a wire connecting with the circuit. Because in a conductor or wire, simply what will flow only? Electrons will only flow. Whereas within the p-n junction diode, holes and electron both are flowing, because hole and electron both are the charge carrier inside the p-n junction diode. But the case it can be happen like this external electric field which you supplied to this p-n junction diode is less as compared to internal electric field, so that the potential difference maintained by this battery or cell B will be less than the barrier potential. Yes, if this B, the B is the potential difference applied by the battery or cell, is less than the barrier potential, under this case, the hole from P region, the P side, and electron from N side are not able to cross the depletion region. They cannot cross the depletion region because they doesn't have the sufficient electric field to cross the junction. Under this case, no current will flow. Okay, no current will flow through this circuit, and even no current will flow inside the junction, p-n junction diode. Okay, and under this case, the p-n junction diode will not conduct. The p-n junction diode will not conduct if B is less than BB. Okay, and we can simply say that a very small amount of current which might flow, okay, due to the flow of means minority charge carrier, okay, but that can also be very neglected. Okay, but if B is less than BB, then almost very less current which flows in the p-n junction diode, and that current which flows even is due to the minority charge carrier. The electron flows this end and hole flow this end. Okay, but if B is less than BB, the majority holes and electron, they cannot cross the depletion region. So when they cannot cross the depletion region, then definitely what happens? The current will not flow through the circuit. Okay, so this is the case. But what happens if B is greater than equals to BB? That means if the electric field E is supplied to the p-n junction diode is such that if the potential difference maintained by the cell or battery is less than or greater than or equals to barrier potential. So under this case, what happens? The hole from P region and the electron from N region are able to cross the junction. They are cross above the junction means they can able to move through the depletion region. So under this case, a large amount of current, large amount of current will flow. Thus, the p-n junction diode will conduct under forward bias. But under what condition they will conduct electricity or conduct current? When B is greater than equals to BB. That means when the voltage supplied to the cell or battery is equals to barrier voltage or more than barrier voltage, then only under that case hole and electrons, which are the majority charge carrier in p side and n side, they can able to cross the junction. When they cross the junction, then the large amount of current can flow through the junction. That's why under forward biasing, the current conduction takes place basically under this case, whereas current conduction does not take place under this case. Okay. So under forward biasing, children, remember this point, due to this electric field, external electric field, it helps the hole and electron to push toward the junction. So when the hole and electron as the majority charge carrier are pushed towards the junction, then what happens? The depletion region, the width of the depletion region decreases. Okay, when the width of the depletion region decreases, then what happens? Under this case, the diode, p-n junction diode offer less resistance. Offer what? Very less resistance for the current to flow in the p-n junction diode. Under what bias? Forward bias. So basically p-n junction diode works under what bias? Forward bias. Is due to the external electric field will be in the direction opposite to the internal electric field, and this external electric field helps the hole and electrons, which are the majority charge carrier, to move towards the junction. And when they are moved towards the junction, the depletion region with decreases and diode offer less resistance. When diode offer less resistance, then majority of the current which flows to the p-n junction diode. But current flows, as I said, under this case, whereas current does not flow under this case. So this is the detailed explanation of p-n junction diode under forward biasing. So in the next YouTube video, you learn the p-n junction diode working under reverse biasing.